Okay, so let's start with situation B. So in this case, I'm giving you the forces and you need to find the net force. You need to find the net force in the x and y direction. Now in some cases it's very simple, and that's fine. Right now you always need to explain how you got it, either by showing the math or by explaining your answer. Both of them are relatively simplistic in some cases, so I don't care which one you pick. So the first thing we need to do is find the net force in the y direction. If you want to find the x first, you can. I'm going to do the y. So you write it down, F net y. Okay, how do we find that? We combine all the y direction forces. So that's up and down. In this case, we have the 3 newtons from the normal force up and the 3 newtons from the force of gravity down. So you're going to add the two values together. 3 newtons, 3 newtons. Now be careful about the directions because arrows tell you direction matters. So the net force is going to be whatever direction wins out. Think of tug of war. If the up is more, then it's positive. If the down is more, then it's negative. So the normal force, 3 newtons, is up, is positive. The 3 newtons from gravity is down, so it's negative. So it's positive 3 minus 3. So 3 newtons minus 3 newtons gives you a net force of 0. That makes sense because it shouldn't be going up or down. It should be sitting on the surface, whatever this thing is. Now we do the x direction. Same thing. Net force in the x direction, you add all the forces up, left and right. Everything right is positive, everything left is negative. Notice that there's nothing right. There's nothing right. So I don't include anything. If you want to write 0, you can write 0, but I'm going to leave it blank. We have friction to the left of 5 newtons. Left is negative, negative 5 newtons. So the net force up in the y direction is 0. The net force in the x direction is just that negative 5, and that's it. Notice that it's okay to have a non-zero net force. This means it's slowing down, which could definitely be the case due to friction.